See this, initially you are taking 300 gram of radioactive substance, half-life is 3 hours. After 18 hours, how much substance will remain is the question. Now everybody should know that every radioactive disintegration, it follows the first order kinetics. It's first order kinetics. And I know that in the first order kinetics, T half is independent of reactant concentration present at initial point. Now 300 gram initially the substance you have, after half-life it will become 150 grams. I know half-life is 3 hours. After that one more 3 hour, total becomes 6 hour. One more 3 hour, it will become 9 hours. One more 3 hours, it will become 12 hours. So one more 3 hours, it will become 15 hours. The one more 3 hour, it will become 18 hours, right? You're saying that whatever is initial reactant concentration, half-life will remain same. I know it because I derived the first order kinetic half-life time expression where it says that it is independent of what is the initial reactant concentration, right? Yeah. So 150 divided by 2, 2 7s are to 5s are. 2 3s are 1 remain, 2 7s are 1 remain, 2 5s are. 2 1s are 1 remain, 2 8s are 1 remain, 2 7s are 1 remain, 2 5s are. 2 9s are, 2 3s are 1 remain, 2 7s are 1 remain, 2 5s are. 2 4s are 1 remain, 2 6s are 1 remain, 2 8s are 1 remain, 2 7s are 1 remain, 2 5s are. So after 18 hours, 3 hours, 6 hours, 9 hours, 12 hours, 15 hours, 18 hours, 4.6875 gram of the radioactive substance will remain. That is given at option A. Let me tell you, every radioactive decay, it follows first order kinetics. So the answer here is option A.